All right, welcome. So now we're going to talk about how to use exponential functions when we compute compound interest. So with simple interest, you're only calculating interest on the principal amount that's invested, and that's it. So it's a one-time thing, or if it's multiple times, it's only on the principal. It's never on the interest. So if you have $1,000 and you're getting let's say for 5 years, and they're going to pay you 10% each year, and it's simple interest, like in a CD or something, then you're only going to make $100, 10% of $1,000 each of the 5 years that you have that investment, if it's simple interest. If it's compound interest, year one you make, let's say, the interest on the principal, and then year two you make interest not only on the principal amount, but on the interest that you earned in year one, and so far. So it compounds, right? So now, how do we use exponential function in the compound interest? Well, let's derive it, okay? So let's say you've got an interest rate, R, and you've got a principal amount that you're depositing into an investment, or you're borrowing, in the case of a loan. And let's say for A1 is the accumulated amount after year one. And so what happens? You're going to have at the end of year one, you're going to have your principal in the investment plus the interest that you earned. And what's the interest? That's going to be R times P. The interest rate times the principal is your interest. Okay? So in this case here, this becomes what? P times 1 plus R. Okay? Now, what about at the end of year two? Well, at the end of year two, you're going to get what? Obviously, you're going to get the amount that you had at the end of year one plus the interest that you earned on the amount of money in your investment during year one, or during year two, which would be what? The rates times the amount you had at the end of year one. Okay? But A1 is equal to this. So let's substitute in for that. So that would be what? It's going to be P times 1 plus R plus what? R times P times 1 plus R. Okay, now what happens here? This is going to equal what? If we factor out the P, what do we end up having? We end up having, well, it's going to be R plus R squared here, because we're going to distribute the R. That's going to be, give me R plus R squared. I've got 1 plus R, so we're going to have 1 plus R plus R plus R squared, right? That's what this gives us, right? So I factored out the P. That's going to leave this plus this, so the R distributes. I get R plus R squared, and I put it all together, I get this. But if I add the two R's, right, that's going to give me 2R. So that's going to be 1 plus 2R plus R squared. Well, this is factorable, right? 1 times 1 will give me 1, and if I add them, I get 2. So this will give me what? 1 plus R quantity squared. It's a perfect square. So it's going to be 1 plus R squared. Okay, now let's do one more. So A3 equals, again, it's going to be A2 plus the rate times A2. And now this is A2, so let's plug in A2. So that's going to be P times 1 plus R to the third, or excuse me, to the second, plus R times P times 1 plus r squared, right? So now what happens? So again, I'm going to factor out the P, right? And in this case here, what happens? I'm going to factor out the 1 plus r too. So I get 1 plus r squared, right? So I factored out the 1 plus r squared, and look what that gives me. So basically I'm factoring out this factor right here. What does that leave over? That leaves me 1 plus r, and look at that. It becomes 1 plus r cubed, right? So this basically gives me cubed. Well, if we keep going, do you see the pattern? Well, that means if I just keep going and I say, okay, a to the k, right? A sub k after k years is going to equal p times 1 plus r to the kth power. Now, since we're talking about years, we're talking about time, this becomes the formula for compound interest over the number of years, which would be a equals p, your original principal, times 1 plus the rate raised to the t power. Okay, so this becomes an exponential function. So this is a sub t, or a of t, so it's an exponential function that represents compound interest over t years, where the rate is an annual interest rate. And now we'll go from there.